Hey guys, I'm YD. This video will give you a brief introduction to my course project of the EE538. It will just take a few minutes. First, let's look at the overview. My situation was that I finished both the last two assignments and this course project all by myself alone, so I hardly had any spare time to do the optional tasks in this project. But luckily, I have finished all the required ones on time, which are the 10 items here, and the following content will be about that. All my code is written in Windows 10 subsystems for Ubuntu 18, so I need to use an X server to show the OpenCV images. But if you normally want to run or test my code in your Linux or MacBook, you don't need to do this. All you need for the preparation is to follow the guide in this README file, where you can find some original instructions which will show you how to set up your environment. After you finish that, you can type make run to compile and run the main function of this project, or you can also type make test in your command line to run the unit test. The project is managed actually by Bazel, but personally I'm accustomed to using make, so you can also use that Bazel. Then let's go through each task in detail. Actually, I don't think there is too much to show in these basics tasks, since the first several tasks, like the first one, I just go through all the data and select those which start with the input prefix and return them, which is rather easy. I use a lot of algorithms from the standard library, like the standard find if, standard remove if, or something else here, because there's no need to reinvent the wheel. And these standard library algorithms make my code rather simple, especially for the first few tasks. And in the second here, fourth, fifth, and the last functions, I also similarly go through all the items in the data member and put the valid ones in the result before I return it. For the shortest path algorithm, the Dijkstra one here is much faster than the Biermann-Foote one, because the Biermann-Foote one needs a lot of initializations here to save all the edges from the graph, which I know can be optimized, but there's no time for me to finish that, so it runs slowly here, although it's correct. The cycle detection uses DFS algorithm here for every node, and once we revisit a previously visited node, there will be a cycle in this subgraph. The topological sort will automatically remove the nodes with no dependency from the dependency list until the list is empty. And the last one is the TSP. I only use some recursive functions here in this problem. Although there was DFS algorithm previously, I still use non-recursive implementation for all the functions before this problem. The three methods here give you the same result, but the sophisticated one runs faster. In addition, we can also run the unit test for all those functions besides running them manually from the manual. I wrote 3 test cases for each of them. Truth be told, I actually need more time on this project because there are still many things can be improved, like the Biermann-Foote algorithm, the optional tasks, writing a GUI for my program. Finally, please let me give my sincere thanks to the professor and the TAs for their help. And that's all for the content. Thanks for your listening.